Hi, and welcome to our Payments Explained video mini-series. This is part 2 of the AI testing approach for ISO 20022 migration video, in which we will dive deeper into the approach we use to develop comprehensive test libraries that can support a multi-aspect technology migration of a complex, large-scale financial system. If you missed our first video, follow the prompt on the screen or the link in the description of this video to make sure you see that first. I'll remind you that Exactpro's independent quality assessment approach is called AI testing. It is customized for financial sector implementations and based on Exactpro's best practices obtained from testing a variety of mission-critical financial systems over the course of more than 15 years. The approach works across the entire spectrum of domains and use cases, spanning payments, including CBPR+, securities, clearing and settlement, fund management, and Forex, among others. Our projects over the years have featured supporting the quality aspects of investment banking, post-trade, and real-time gross settlement systems, giving us extensive experience in ISO-related migrations. When applied to testing a core banking system for ISO 20022 compatibility, AI testing helps ensure seamless payment processing and message interoperability, thus helping clients achieve a high level of operational resilience and demonstrate full regulatory compliance. This AI testing in investment banking schema defines the testing steps involved in a technology migration process and the role that subsymbolic AI methods play in it. Subsymbolic AI largely relies on machine learning methods for training and pattern detection. Let's briefly outline the goals of each testing step. Step 1 is test basis analysis. It's where we analyze all input data to shape the input dataset. In step 2, we shape the input dataset to be used in generating tests, an expected outcomes dataset to be used for test generation by our core digital model of the system under test, and further reconciliation of the expected and received results. The core system under test model will be further fine-tuned based on the analysis of test inputs and outputs. Step 3 is test execution, meaning running the test we have generated against the system under test and compiling the output dataset with the actual results we received. In step 4, we start enriching the output dataset with annotations as we interpret the system data we have received. In the next step, model refinement, we analyze the information we had received to identify defects, as well as to refine the test suite and the model generating the expected outcomes. It's worth noting that this is an iterative process that is connected with step 4. Test reinforcement and learning. The focus of this step is working with the weights dataset, the dataset of fully annotated and weighted scenarios to assess and compare their performance, with the goal of eventually arriving at a highly optimized list of best-performing tests that form the test library. The final test library is a subset of select scenarios, fine-tuned until the maximum possible level of test coverage is achieved, with the minimal reasonable number of checks to execute. Carefully optimizing a subset of test scripts results in achieving a significantly more performant and less resource-heavy version of the initially generated test library. Unified storage of all test data in a single database enables better access to test evidence and maximum flexibility for applying smart analytics, including for reporting purposes. The final test coverage report helps demonstrate property and rules checks between input and output data and traceability between the requirements and the test outcomes. Let's now focus on the testing and validation process for ISO 20022 workflows, more in depth through the illustration of two scenarios. In the first example, Bank A has migrated to ISO 20022 and requires validation of the transition and its new MT to MX conversion capabilities. And in the second, Bank A has not migrated to ISO 20022 but developed a converter that also requires a technology acceptance assessment or external validation of the conversion capabilities. The two sample infrastructure schemas also feature a test environment for message reconciliation, system performance, and other testing conducted during the transition. Let's start with the first example. As you can notice, the validation steps are structured similarly to what we described earlier in the investment banking test framework schema. The test basis represents the analysis of all data available from the system logs and other formal and informal sources. After a thorough analysis, the gathered data is being normalized and converted into machine-readable form. The input dataset and expected outcomes dataset is derived from the knowledge gathered in the first step. In our example, it's transposed messages from the legacy systems which were recorded for the replay and baseline purposes. The test execution and output dataset step. This is where analysis meets the execution in the AI-enabled test framework, which performs the conversion of the recorded legacy messages into the new format per ISO 20022. All possible test scripts modifications are being executed and further automated in testing. Then, the test scripts are executed against the system under test, and the results are captured for further analysis and reconciliation between the new and old systems. Enriching the output dataset with annotations. The output dataset is attributed annotations for interpretation purposes. They are subsequently used in AI-enabled analytics. When it comes to integration testing, the output datasets are formed from the traffic captured at the integration point. This dataset is subsequently checked for anomalies and unexpected rejects from counterparties compared to the modeled expected data. All discrepancies detected here are being investigated. Model refinement. This step plays a major role in the development of the digital twin. The property and reconciliation checks mentioned above happen in iterative movements between step 4 and 5. The model logic is gradually trained and improved to provide a more accurate interpretation of the output dataset and to produce updated versions of the expected outcomes and interpretation datasets. Test reinforcement and learning and dataset weights. This step consists of the discriminative techniques which are applied to the test library being developed to identify the best performing test scripts and reduce the volumes of the tests required for execution to the minimal amount. At the same time, the main focus would still be on covering all target conditions and data points extracted from the model. In the example illustration, this step links the fifth and the first step, allowing us to re-evaluate the input dataset. It directly influences the model refinement based on the information obtained from testing and focusing on automation coverage, stability, and verification improvements. The second illustration example follows the same steps of the AI-enabled test framework, with the difference in the kinds of datasets being captured for further analysis and test execution, as well as the collection points for that data. Read more about the approach for ISO on Exactpro's website. To recap, when engaged with clients on an initiative such as an ISO 20022 migration, we use the AI testing approach to create a performant and resource-friendly version of test library to help validate the transition and also perform regression testing later in the system's lifecycle. Parallel, or in addition to that, the Exactpro team can conduct an in-depth exploration of an existing ISO 20022 related testing practice by assessing the current test strategy, test library, and the surrounding processes, and providing actionable insights on potential enhancements and efficiencies that can be introduced in your organization, including those driven by AI testing. If you'd like to receive a detailed plan of testing and validation checks involved in an ISO migration, leave the phrase ISO 20022 testing roadmap in the comments below and we'll get back to you shortly with an extended version of our materials. You can also reach out to us via info@exactpro.com to start a discussion on how we can help streamline your ISO 20022 adoption journey. And let me also remind you that AI testing serves a broad scope of use cases in banking and beyond. It can be used to drive software development of a new system, facilitate technology acceptance assessment during system migration from legacy to newer platforms or protocols, as well as enhance the quality assessment framework in an existing infrastructure. With this, we've arrived at the end of our video. Thank you for watching, and I'll see you in the next episode.